And there's a copper wire in the form of a square frame. So here a current I is flowing through it. And there's a uniform magnetic field which is tangential to the wire frame is applied. The weight mg, how will act? Vertically down. G will be in this direction. It's asking now what is the minimum current that should pass through the wire to make one end lift off the table. How the dipole moment? Dipole moment will act vertically down. There's a M bar cross B bar, and B bar is like this along x-axis. M bar cross B bar. How the torque? So if I introduce the x and y axis here, this will be x-axis, y-axis. Let this be z-axis. Okay, now check it. This is the direction of current. M bar cross B bar. So how the torque due to dipole moment? So it should be in this direction. Sense. How the torque due to weight? So this is about. So but here what happened is telling what is the minimum current that should pass through the wire to make one end lift off the table. So what is the effect of the torque due to dipole moment? It will try to lift it, no? It will try to topple about z-axis anti-clockwise. It should tip that one. So here can we how to bring that minimum current? So shall I say shall I take it A, B, C, D? It will try to tip about AB. So this total wire lies in on a table. So what is the XZ plane? XZ plane is what? The surface. I think it didn't give enough diagram. This is the surface. This is a loop. Okay, fine, at least now. Or there's a ground, you better write it. There's a condition what is available. How mg will act vertically down. Then about which side it can tip. It can tip about AB. So torque due to dipole moment. So about AB, I'll go for torque. About AB, the torque, that one, about axis. So instead of this, let me just show that one. Bring the problem, make the problem like this. So torque due to weight. So the weight will act mg by 2, mg a by 2. So torque due to weight or torque due to dipole moment equal torque due to weight. Torque due to dipole moment should be equal to I into a square. Should be torque due to weight mg into a by 2. So bi a square. So one a will get cancelled. So what is I is equal to mg by 2ba. If the current is greater than this, it will tip about AB. If just it's about to tip, if current is made greater than AB, no, mg by 2ba, it is going to tip about AB. But something the torque, here there's nothing, the torque will be set up about, so you can ask question like suddenly you are moving away from the basic concept. The torque will be set up about axis passing through center of mass. Torque should, that one. So I'm not analyzing like this, no. This is the center of mass. So I'm showing it here. Is it justified? Is it justified? because instead of discussing the problem about that red color dotted line, we are shifting about axis CB. So what is the impact of, say, like even the torque is acting about this. So what this torque will do, it will try to rotate, it will try to rotate the loop, that one, and because of that, what happen, the axis of rotation will become fixed. Are able to get into the problem? Don't end up just answer. So why the, sorry, the torque due to dipole moment you are supposed to show here, you can see that, and first you are shown, then you shifted. What is the reason? The first, like the torque is set up here, let's assume that one, because of torque due to dipole moment, what happen, it try to rotate the AB. What happen, the side AB will be pressed against the ground, so the axis of rotation now will become fixed about AB, and the torque due to dipole moment will be set up about AB. Say anyway, it's a parallel, no, this one, and the torque due to weight will come into picture because this side CD will try to lose contact. Side AB will be slightly pressed down into the ground, or push it, you can better push it into the ground. So then we have to discuss the torque about AB now. Now it will become like a fixed axis rotation about AB. I think you have to be very careful here about the numericals. When it comes to application problem, no, torque set up by the about y-axis, it can be parallel to y-axis also, parallel to z-axis here. Just now I'm deviating that the torque due to dipole moment should pass through center of mass. We said here. Is it a fixed axis rotation now? So take the effect of the torque about that fixed axis. Or else, shall I suggest you what is another method? Leave this torque due to dipole moment. Calculate force acting on individual arm, then work out. You will get the same answer, you see. What is the force on AB? So there is a current flowing here. This, if you are unable to digest it, so torque due to the dipole, or torque due to the current flowing in the wire. So torque due to AB will be torque due to dipole moment. Or so torque due to magnetic field will write. What about the B bar? The force acting on the wire AD and CB will be zero, no? First, I'll categorize the forces. Wire AD and CB will be zero. Anything? Why? Ampere force. Because B bar and current are in same and up. For AB, the L bar will measure in the direction of field. And for CB, what pen will measure L bar opposite to B bar. So sine 180, sine 0 will become, the force will be 0. Since it will tip about AB, so what all force will be set up, it will pass to axis of rotation. So about AB, what happened? The ampere force will not set up any torque. The ampere force will not set up. Okay, now due to DC will calculate. What is the force DC? Force DC should be equal to B A I. What about the direction? B bar. So it will be along y-axis. The force will be. So look at this force. It will set up a torque, no? Torque due to magnetic field. Only this force can set up a torque. So how much it is? A I cap cross F DC bar. I cap I. So I cross J will be K. So B A square I K cap. So fine. So that the same thing is what I wrote, no? This is actually the thing. I suggest you better to think in this way. Now, why the torque due to FAB will not be there? Because FAB intersects axis of rotation. Therefore, I didn't consider. FAB will also act, will be non-zero, but torque due to this will be torque due to this force will be zero. So like this, you will get idea of toppling. See the center of mass. Toppling also will be introduced in this particular numericals. So I took a simple case of square frame. So different types of frames will come. So they may, and the frame will have a weight, and the toppling can be introduced here. Let's take one more. This one, no? Oh, no, the last one. A ring of radius r having uniformly, I think this time not there, no?